The third type of transformation that we want to talk about with graphs of functions is the non-rigid transformations, or the shrinks and the stretches. Unlike the other shifts that you've seen where we're moving left or right, up, down, or we're doing reflections, these ones, the graphs do not change their shape. We simply pick them up and move them to different places on the coordinate plane. Non-rigids, however, can change their shapes in that they can pull towards one way or another, or they can change their slope. Similar to what you saw before, if you see a coefficient or a number on the outside, that's going to be a vertical. If you see something on the inside of a function, that will be a horizontal, just the same way that you had up-downs were on the outside and left-rights were on the inside. So this one right here, f of x, 2 times the absolute value of x, that's going to be a vertical change of some sort. The question is it going to stretch it vertically and pull it, or is it going to shrink it and condense it vertically? So let's go ahead and look at the graph for this one. Absolute value of x, 2 times the absolute value of x. Here's the parent function, and this is the change, 2 times x. So we see that even though it has the same kind of basic shape, the slope has changed. Here you have a slope of 1, here you have a slope of 2, and it's changed this way, it's gotten taller, so it's a vertical stretch. We might then also ask ourselves, what happens if we have a different number in front, where it's not 2, but let's say it's a 0.2. Parent, and then the change. Vertically, we're not pulling it upwards. In fact, it looks like we've squished it downwards, and so it's a shrink that's happening. So if you have a number on the outside that's greater than 1, we're going to call it a shrink, a stretch. Greater than 1. And a shrink, not just if it's less than 1, but if it's between 0 and 1. So if it's a decimal or a fraction between 0 and 1. Here we have example B with an absolute value, and this time the number is on the inside, and we would expect that this should be a horizontal of some sort. So the parent function again, horizontal change. Think about how horizontally it's going outwards like this, and then this one has a much smaller horizontal range that we're looking at. It's been a horizontal shrink. And you might be saying, well, why is that? Because isn't that greater than 1? Yes, it is. But remember, horizontals are funky. Remember how last time we had horizontals and we had them for the insides? We said it was always the opposite of what we expected. So that when you saw a plus, it was actually going to the left. When you saw a minus, it was actually going to the right. It's going to be the same thing here. When you see a horizontal, you might be thinking, oh, it's greater than 1. Won't that stretch it outwards? Instead, it's shrinking it inwards because it's the opposite of what we think. So shrinks are greater than 1, which means that our stretches will be between 0 and 1. So again, just watching out for these opposites of what you think. This one here then, this gives us a chance to kind of test our thoughts. We see a number on the outside, so that should be a vertical. And then we see that it's a 0.5, so it's between 0 and 1. So this should be a vertical shrink. That's what we think here. Let's go back and check it. So here's the original function, x plus 3 cubed, and then we're going to put a 0.5 in front. The original. And sure enough, a very slight shrink. Again, we're looking at the slopes. If here's the original, then the next one in here is not rising as steeply, and it looks like it was ever so slightly pushed together vertically. So a vertical shrink. Let's say you didn't have the 0.5. Let's say it was just that 5. Again, it's increasing more steeply, so that would be a vertical stretch, pulling it outwards. So that's following our rules of what we think. This one here, because as a negative, remember about reflections, this one would also be reflected over the x-axis. So same as your other transformations, outside coefficients mean vertical, insides mean horizontal. Watch out for your stretches and your shrinks. Verticals are what, quote, makes sense to us, the common sense. Horizontals are the opposites of what you think.